is a pretty complicated question. We've got a solid sculpture with a 4 by 4 by 4 cube and a 3 by 3 by 3 cube sticking out as shown. This is the 3 by 3 by 3 cube. Three vertices of the smaller cube lie on the edges of the larger cube the same distance along each. So what it's saying is that these three are the same. Now if I highlight the points then, so here, here and here, that's where the vertices are lying along the larger cube. Now, first of all, I'm going to continue the 4 by 4 by 4 cube as if just the dotted line that kind of makes up the whole thing. So it's going to look like that. And then I'm going to join these vertices together. And this triangle is actually going to form the base of a pyramid. Now, this pyramid is, so because the kind of these two cubes are going into each other, we're going to get actually two pyramids inside. It's quite complicated to think about, but we're going to get a pyramid from the corner of the 4 by 4 by 4 cube, where it's that's where it's no longer overlapping. So this is a pyramid and it's actually pointing towards us. Let's also think about the 3 by 3 by 3 cube. So if I continue that one, then it's going to come down. It's going to look a bit like that. So that is going to form a pyramid that's pointing into the 4 by 4 by 4 cube. Again, yeah, here's the base. It's the same base as before. Now let's focus on the pyramid on the right. I'm just going to sketch it out in a slightly different orientation. So this is the base, which is my equilateral triangle. And then it's going to a point. And then this is going to be behind. So let's just think about what we actually need to calculate. The volume of the sculpture is going to be 4 cubed for the volume of the 4 by 4 by 4 cube, plus 3 cubed for the volume of the 3 by 3 by 3 cube. But then I'm going to need to minus the volume of each of the pyramids, B1 and B2. And to get the volume of the pyramid, it's 1/3 times the area of the base times the perpendicular height. Got all these dimensions to try and figure out. Now focusing on this one here, then this length is going to be 3 because I'm using the side of the 3 by 3 by 3 pyramid. And that one is as well. And that will be a right angle. So I can work out this length here, the base, that one of the lengths of the base. And it's just going to be a diagonal of this 3 by 3 square. And using Pythagoras' theorem, we just get that the diagonal is 3 root 2. That is one thing worth knowing actually. If you've got x and x, it becomes x root 2. Or if you had the hypotenuse as x and these two are the same, it would be x divided by root 2. Of course, you can do Pythagoras in full. It would be 3 squared plus 3 squared. That's 18. Then square rooted, which becomes root 9 root 2, which becomes 3 root 2. So this is 3 root 2. This length is 3. And the other two lengths at the top are 3, and the other two along the bottom, this one and this one, are also 3 root 2. Now what I see on the left-hand pyramid is the same length, 3 root 2, and then these two are the same, and this is a right angle, so they must also be 3. Which means when it said that the 3 vertices of the smaller cube lie on edges of the larger cube the same distance along, that's telling me the distance along now. So this little distance would be 1. And what we actually have are two identical tetrahedrons. Actually, this is called an octahedron because they're pointing in opposite directions. You could look up what they look like if you can't quite visualize it from here, but it's just a pyramid and an upside down pyramid joined together. So actually, I don't need to work out these two volumes. I just need to work out the volume of one of them and then double it. So let's first of all deal with this area of the base. I'm going to draw it now as that's meant to be an equilateral triangle. 3 root 2, the rule, 3 root 2. And then this angle is going to be 60. So there's a quick way of doing this one. We can use the half AB sine C formula. So a half times 3 squared times root 2 squared. Me just times them by 3 root 2 twice, times sine 60, which is root 3 over 2. Of course, you need to know your exact trig values for this one. The root 2 squared becomes 2 and cancels out with the half. And that leaves me 9 root 3 over 2. I've got that bit sorted. Right, let's say you didn't know that formula. You can still do it. We can split the triangle into 2. So I would now work out this length is just a half of 3 root 2, so it's 3 over 2 root 2. And then I don't want to call it the height h because I'm using height somewhere else. Let me call it x. Then x squared would be 3 root 2 squared minus 3 over 2 root 2 all squared. That will be, remember it's root 18, so 18 minus, then if I'm dividing, actually I just need to divide root, no, let me square them individually. 9 over 4 times 2 becomes 9 over 2. And that is 36 minus 36 over 2 minus 9 over 2, 27 over 2. So x will become root 27 over 2, which I could write as 3 root 3 over root 2. And from that, we get the area of the triangle. It's going to be a half times the base, which is 3 root 2, times this height, 3 root 3 over root 2. These root 2's cancel. And again, we're going to be left with 9 root 3 over 2. Now for the heights. And I think this is the trickiest bit, unless I'm missing something. The solutions just say apply Pythagoras' theorem twice. I think there's a bit more to it, but if I have missed something, please let me know. So I've got the blue dot here, which I'm now going to make green. That's like the bottom, that's directly below the peak. So if I draw this line coming down, that is going to be the height. And what I can do is draw a line to that corner. This will be a right angle, and then draw this line coming down, and I'll have a right angle triangle, which I'm now just going to draw in 2 dimensions over here. So H and 3. What I really need is this length. So if I take a look again at the equilateral triangle, the base, and put the dot, like this dot is directly below, then what I'm trying to work out is this length here. That is also my question mark. I can draw a line coming down here. And then this, see, I already did that work before when I did the alternative version to the area of the triangle. This length here is going to be 3 over 2 root 2. So I'm going to keep it as question mark. Now, actually, I do know this length kind of, because this whole purple length is 3 root 3 over root 2. It's the x that we found above. But also, this now purple length is the same as this length. So that means the bit I'm pointing at is going to be 3 root 3 over root 2, the full amount, minus question mark. Got right angle triangle, we can apply Pythagoras' theorem. So it must be that question mark squared is equal to 3 over 2 times root 2 all squared. That's 9 over 4 times 2 plus 3 root 3 over root 2 minus question mark. Now, if there's a quicker way to do this, because this seems quite complicated, then please do let me know. I'm going to get 18 over 4 plus, then I times these two together. I'm going to get 27 over 2. Then minus 3 root 3 over root 2 times question mark, but then doubled. That will give me 6 root 3 over root 2 question mark plus question mark squared. So these two cancel out, and I've got 0 on the left-hand side. I can rewrite it as 6 root 3 over root 2 times question mark is equal to, put this over common denominator, 27 over, I can write 18 over 4 as 9 over 2. That's going to be the easiest thing. And that will become 36 over 2, or 18. So then question mark, I will divide by 6 to give me 3, times by root 2, divide by root 3. Actually, 3 is just, well, I could rationalize the denominator, times top and bottom by root 3. That will give me 3 root 6 over 3, or root 6. Hey, that is my answer there. So that is this value here. And therefore h, it's much quicker now, h is going to be 3 squared minus root 6 squared, which is 6, square rooted, 9 minus 6, 3, so the square root of 3. For the volume is going to be 1/3 times that area that I found, 9 root 3 over 2, multiplied by the height, which is root 3. The root 3's become 3, they cancel out with that, divided by 3, and I get the volume of each of the tetrahedrons to be 9 over 2. Which means finally, the volume of the whole sculpture is going to be 4 cubed, 64, plus 3 cubed, 27, minus 2 lots of 9 over 2. Remember, there are 2 tetrahedrons here, so I'm minusing 9. That gets me 91 minus 9, which gives us the answer of 82. Well done.